Argon is a chemical element with symbol R and atomic number 18. It is in group 18 of the periodic table and is a noble gas. Argon is the third most common gas in the Earth's atmosphere, at 0.934%, 9,340 ppmv, making it over twice as abundant as the next most common atmospheric gas, water vapor, which averages about 4,000 ppmv, but varies greatly, and 23 times as abundant as the next most common non-condensing atmospheric gas, carbon dioxide, 400 ppmv, and more than 500 times as abundant as the next most common noble gas, neon, 18 ppmv. Nearly all of this argon is radiogenic argon-40 derived from the decay of potassium-40 in the Earth's crust. In the universe, argon-36 is by far the most common argon isotope, being the preferred argon isotope produced by stellar nucleosynthesis in supernovas. In addition, argon is the most prevalent of the noble gases in Earth's crust, with the element composing 0.00015% of this crust. The name argon is derived from the Greek word neuter singular form of meaning lazy or inactive, as a reference to the fact that the element undergoes almost no chemical reactions. The complete octet, 8 electrons, in the outer atomic shell makes argon stable and resistant to bonding with other elements. Its triple point temperature of 83.8058 K is a defining fixed point in the International Temperature Scale of 1990. Argon is produced industrially by the fractional distillation of liquid air. Argon is mostly used as an inert shielding gas in welding and other high-temperature industrial processes where ordinarily unreactive substances become reactive. For example, an argon atmosphere is used in graphite electric furnaces to prevent the graphite from burning. Argon gas also has uses in incandescent and fluorescent lighting, and other types of gas discharge tubes. Argon makes a distinctive blue-green gas laser. Argon is also used in fluorescent glow starters. Argon has approximately the same solubility in water as oxygen, and is 2.5 times more soluble in water than nitrogen. Argon is colorless, odorless, non-flammable and non-toxic as a solid, liquid, and gas. Argon is chemically inert under most conditions and forms no confirmed stable compounds at room temperature. Although argon is a noble gas, it has been found to have the capability of forming some compounds. For example, the formation of argon fluorohydride, HARF, a compound of argon with fluorine and hydrogen which is stable below 17 K, was reported by researchers at the University of Helsinki in 2000. Although the neutral ground state chemical compounds of argon are presently limited to HARF, argon can form clathrates with water when atoms of it are trapped in a lattice of the water molecules. Argon containing ions and excited state complexes, such as R+ and ARF, respectively, are known to exist. Theoretical calculations have predicted several argon compounds that should be stable, but for which no synthesis routes are currently known. Argon, neuter singular form of Greek meaning inactive, in reference to its chemical inactivity, was suspected to be present in air by Henry Cavendish in 1785 but was not isolated until 1894 by Lord Rayleigh and Sir William Ramsay at University College London in an experiment in which they removed all of the oxygen, carbon dioxide, water and nitrogen from a sample of clean air. They had determined that nitrogen produced from chemical compounds was 0.5% lighter than nitrogen from the atmosphere. The difference seemed insignificant, But it was important enough to attract their attention for many months. They concluded that there was another gas in the air mixed in with the nitrogen. Argon was also encountered in 1882 through independent research of H. F. Newall and W. N. Hartley. Each observed new lines in the color spectrum of air but were unable to identify the element responsible for the lines. Argon became the first member of the noble gases to be discovered. The symbol for argon is now R, but up until 1957 it was A.